In this video, we are going to discuss about instance-based learning versus model-based learning. Now, guys, whenever we solve any specific use case, right? And let's say that for this particular use case, I really want to create a model, and this specific model will be, let's say, I'm creating a machine learning model, and this machine learning model will actually help us to solve some problems. Let's say a regression or classification problem, right? Let's say I'm trying to solve a regression or classification problem, right? Now in this, if I really want to find out what is the exact differences between instance based and model based learning, usually this machine learning model learns about the data in various ways, right? The first way is basically through the instance based techniques, and the second way is basically through the model based techniques, right? Now when I am actually dividing this two, I would also like to probably, and this entire differences is based on the learning patterns of the model. That basically is how the model are able to understand the data. If my model is completely dependent on my training data, let's say if it is completely dependent on my data, and for doing every prediction, it will be dependent on this specific data. So based how the data actually exists over here, based on that we will be getting some specific output. But in the case of model based technique, whatever data we use over here, you know whatever data we use over here, what this model based technique does is that it tries to understand the pattern within this specific data. Okay, within this specific data. And once it understands the pattern with respect to this specific data, it creates a generalization method to make the prediction for new data, right? And this generalization method is far more better when compared to this instance based techniques, because in instance based technique the model is just dependent on the data that it has currently, and whenever a new data basically comes, based on this particular data only, it tries to predict the output. It's just like a domain expert kind of thing. Let me give you an example, okay, so that it will help you to understand. Now let's say that you have features, and this specific features are like number of play hours. Okay, let's say I'm using this features: number of play hours, number of study hours, number of study hours, and the last column is there whether the person is going to pass or not. Okay, or pass or fail. Now let's say that if I have this three specific features, okay, and these are the features with respect to whether for a student, right, how many number of hours he or she is playing, how many number of hours he or she is studying, right? And then we need to predict whether the person is going to pass or not. Now if I probably take this particular data points, right, and if I just try to plot this particular data points over here, okay, so let's say this is play hours, this is study hours, okay, and you know that this will be inversely proportional, right? If a person is playing more, right, and if he's studying, or if a person is studying, if the person is playing more and he's studying less, then I can suggest that he may probably not pass, right? So I may have different data points over here. Let's say these are some of the data points. Okay, let's say these are some of the data points, right? And let's say there are other data points where the person is studying more, and based on that, this red mark that you will be seeing, it is basically saying pass, and this yellow mark is basically saying fail, right? Now in this particular scenario, obviously there will be some kind of outliers also. Okay, like even though the person is playing more, he may his study hours may also be more, and because of that he may pass, right? So there may be obviously some data points from this particular data points, even though he's studying less, he's able to pass that specific exam, right? Now in this particular use case, what happens is that in the case of instance-based learning, okay, This will be just like a domain expert. Just imagine this, okay? This will just be like a domain expert, like how this specific model works. Now in this, just imagine that suppose a new query point comes. Let's say the new query point is somewhere here, right? It's somewhere here. Now what happens in instance-based learning? The model knows the training data. What it is going to do, it is not going to understand the pattern within this data. It is just going to see the surrounding data around it. Let's say if this particular data point is coming, it will see that how its surrounding is basically behaving. If the surrounding is behaving in a way that most of the points are pass, at that point of time, this will actually become pass. Otherwise, if most of the data points are fail, then this will probably be fail. Now here you can see within this circle, most of the data points are fail. So this will actually behave in that specific way, and this will, the new test data will actually show it as fail as an output, right? So here specifically it is focusing more on the training data, or you can just say that it is learning religiously from this particular training data, okay? Religiously, right? Now, this is what basically happens in instance-based learning, right? Here you will not be getting any patterns, right? The model will not learn based on some specific patterns. Here you just have a training data, and based on this particular trained data, you will try to learn it and you will try to find out the different kind of outputs. Now, this instance-based learning, there are a lot of different techniques, right? One of the technique that I would definitely like to talk about is KNN, right? K nearest neighbor is one of the algorithm which uses this instance-based learning, right? And we will discuss about this, okay? And there are some kernels also which we are going to discuss about instance-based learning. But if I probably consider the same problem statement with respect to model-based learning. Now let's say if I had a specific model-based learning, okay, and if my machine learning model learns based on this model-based learning, and let's say if I have some of the data points over here, what will happen is that my model will understand the pattern in this data, right? So it's basically understands the math intuition behind this. So it is able to create a generalized model. Now, generalized model basically means that it will be able to perform well even for any kind of data it may probably come in the future. So generalized model basically means it is trying to understand the pattern, what pattern is basically used in this and how it is basically behaving. Let's say these are all my data points. Now, in this particular case, what will happen is that my machine learning model will probably try to, create this kind of line. Let's say it will try to create this curve. Let's say this curve is basically called as decision function or decision boundary, right? That basically means anything that comes below this particular decision boundary, we are going to consider it as fail. And anything that comes above this decision boundary, we are basically going to consider it as pass, right? So this is the basic difference between instance-based and model-based learning. Here, you create a generalized format to learn the data. Generalized format to learn the data, right? To learn the data. That basically means this model is going to behave based on this decision boundary because it has understood the pattern, okay? And this pattern, it is going to basically be used for any future new data to predict whether the person is passing or failing, right? But here it is completely dependent on the current data that it has, based on this data. Let's say if you probably get another new query point, again it will try to see the surroundings, and based on that it will try to take a decision whether it should be pass or fail. So this is what is instance-based learning is, and generalized based model. In terms of a student, just imagine this is more like by hearting the data, right? By hearting the data, that basically means memorizing the data, okay? Memorizing the data, okay? By heart basically means we usually say, right? Again, I should not use this word, but here focus that the model is trying to memorize the data. Here the model is trying to learn the data, okay? Here learn the data. The model is trying to learn the data so that from this learning, it is being able to create a decision boundary. Or I can also say learn the pattern of the data. Okay, just not learn. Otherwise, it will be a wrong word to basically use. So here I can definitely say learn pattern of the data. Learn pattern of the data. So this is the basic differences between instance-based learning and model-based learning. And I hope you have got an idea about it. Now let's go ahead and understand some of the differences. Here are some of the differences. So usual convention machine learning model basically means this is a model-based learning, right? This is model based, this is instance based. Okay. So first of all, prepare the data for model training. Obviously, you'll require the data over here also. Here also, you'll be requiring, no difference over here. Then the second point is train the model from training data to estimate the model parameters, like discover patterns. So here, as I said, here you're trying to do the generalization. You're trying to learn the decision boundaries, right? And this is only possible when you will be learning the parameters, or when you'll be learning the model parameters within that, and from that training data it is being able to identify that. This is a super important one, which is basically discover patterns. Okay, here do not train the model pattern discovery postponed until squaring query received. So that basically means whenever you get a new data point, then only we will try to square this, right? Here no pattern recognition is there in the instance based learning, right? Whenever new data comes, then only we'll be able to identify based on the surrounding data whether it is yes or no, or whether the person is going to pass or fail. Okay, store the model in suitable format. So in most of the models that we'll be using, we will be able to save them in some pickle format file. So this will be able to store it in the hard drive, or will be able to store it in any folder location or any cloud location. There are different types of file format like pickle, HDF5, H5 format, and many other formats. Okay, we also say it as H5 format, right? So definitely we store the model in some suitable format. And whenever we store this particular model in this format, it is basically stored it in a serialized format. Serialized format. That basically means, see, internally some maths equation is there within this particular model. So whenever any data comes to this model, right? So let's say if this is my model, which is in the pickle format or serialized format, whenever we give our input over here, we will be getting some kind of output. So internally here, you'll be having a lot of mathematical equations that will be serialized in the serialized format. Okay, so there is no model to store. Generalize the rules in the form of model even before scoring instance is seen. This is super important because since we have a decision boundaries, it will generalize the entire rule. No generalization before scoring. Obviously, we have seen the difference between them. Predict for unseen scoring instance use models, right? We'll be able to even predict completely new data because since we have created a decision boundary, so that it gives us result in a generalized manner, both for the training data set or for any new kind of data that we are going to get. Predict for unseen scoring instance using training data directly. Okay, so here you'll be able to see, here we are specifically only using training data, okay, to do even the prediction of the new data. Can't throw away any input or training data after model training. So here you can throw the input and the training data even. Okay, once the model is trained, you can just throw it completely. You don't require it. Why? Because now you have a specific model, and this model is in some format. It is in the serialized format, and it has all the decision boundaries and pattern recognition within them. So whenever a new data comes, it will just be able to predict the output. But in the case of instance-based learning, you always require the input or training data. Okay, so let's say after I get my input data, and if I train my model using this model-based learning, and what will happen, I will be able to get my score, the accuracy. Okay, just don't worry that what are all these things, we will learn as we go ahead, right? Now after training our model, we can remove this input data because everything is stored inside this, right? The decision boundaries and all. So any prediction that we give with respect to our new data, it will be able to do it. But in the case of instance-based learning, we always require the input or the training data. Okay, requires a known model form, may not have explicit model form. This is a basic difference. Storing model generally requires less storage because this model pickle file that it is created, it will either be created in KBs or MBs, right? Since we even don't store any training data, so we just create this serialized format of this pickle file. And inside this, you know that it is being able to recognize patterns and decision boundaries it is able to create, right? So these are usually stored in KBs or MBs. Whereas in the case of storing training data generally requires more storage. Obviously in instance-based learning, just imagine in your training data, you have 10,000, 1 million records. So it is obviously going to take more storage space. And scoring for a new instance is generally faster. Scoring for new instance may be slow. The reason the reason this particular point is mentioned that scoring for a new instance is generally fast because our model is in a serialized format. So whenever we get any kind of input, internally all the mathematical equations will quickly get triggered and automatically we'll be able to get the output. But in the case of instance-based learning, it will go and first of all see the surrounding data points, and then it will use some parameters like Euclidean distance, some distance parameters, and then it will be able to finally tell you the output. So obviously, the model-based learning is faster than the instance-based learning. That is what is the outcome that you can actually get from here. So I hope you have understood this, the basic differences between instance-based learning and model-based learning. And the main thing is that from the instance-based learning, you are just learning from the data. You're just memorizing the data. So here, I want to make one point that the learning of the model usually happens by two ways. One is memorizing, one is generalizing, right? And generalizing is a better way when compared to memorizing. But yes, for some of the use cases, we can use memorizing techniques. So memorizing technique is basically my instance-based learning. Instance-based learning. And generalizing is basically a technique with respect to model-based learning. Okay. So this is the basic differences between memorizing and generalizing. So yes, this was it for this particular video. I hope you are able to understand what is the basic difference between instance-based and model-based learning.